for coming around. We had a great time yesterday. We made a very good foundation trying to explain the basic. We provided necessary information needed for us to understand the principle of Pharmacophore-Based Drug Design. So just to recap, we're able to explain that docking does not just stop at identifying your heat ligands, but if you are aimed at discovering a drug, then we go for lead optimization. So Pharmacophore approach is part of that method you use for lead optimization, because it will guide you in creating analogs, derivatives of your heat, other than just modifying the heat anyhow. It will now guide you, enable you to use these pharmacophoric features in designing your drug. So that once you have done a work and you discovered potential binding, potential drug candidates, they do your optimization. Definitely, when you optimize, usually I optimize with up to 50 to 100 ligands. So after my optimization, I do achieve up to 100 or 50. I will now redock with those optimized ligand. You may now observe that some of the analogs might even be better than the original heat you got from docking. Then, other than if you don't want to go through that docking approach, you can now on your own curate analog by yourself. Maybe there's a report that artesunate is better, artesunate is effective. You can say, okay, I want to do a work on artesunate derivatives. So you pick a scaffold and now model up to 100 to 150 artesunate derivatives using these pharmacophoric features. So these are the application of what we are doing. And it's in two ways. We have the design approach and the screening approach. What we are doing in this training is to design. So we are designing the molecule by ourselves. But in the screening aspect, we don't design. We only retrieve molecules. Take, for instance, you have 500 bioactive compounds from your plant, and you want to assess these bioactive compounds if they actually possess, you want to know the ones that possess these macrophoric features. So you don't want to dock everything, you want to reduce them. You can now subject all of them to this test. You can create a model by yourself and test all the 500 bioactive compounds to that model to see the ones that will pass the model. Or you can use some online tools that has prediction capacity, where once you upload your ligands, you set the values, you set all those features, set the range you want. They will screen it and give you just the ones that falls within the range you requested. So that is screening. And we'll be doing that by next 2 weeks, because we have a training. It's still a free training called molecular modeling. That is by next 2 weeks on the 21st and 22nd of this month. So I will also advise some of us who have not registered for that one to try to register, so that it will help you to understand some of the basics in what we are discussing. So quickly, I'm going to share my screen, and we start from what we have to do today. So let me take questions. Is there any question? Do you have a question from what we did yesterday? We had some pending question which I'm going to trash, then we proceed. So we have enough time to do our hands-on training tonight.
Sorry, I sent a message. The video is not downloadable, so how can you help us?
Okay, you want to download the video?
Yes.
But can you watch the video?
Yes.
Okay, and it's consuming your data. Okay, what we do is that we are not supposed to release that video. We are supposed to leave it after the session, but some persons requested that please let us release the video so that they can watch and prepare for today's class. So that was why we, yes, that was why we did it. Yeah. So, but after tonight, then we are going to we're going to allow you to download. Yes, we will allow you to download after tonight class. So is that okay?
Yes.
All right. Thank you. So any other question? So we are good to go, right? Somebody was asking yesterday about
questions. Yeah. Questions.
Yes. Sir. Yeah. Go ahead.
Thank you very much. So I was trying to. Sorry, the question is not about the topic. I'm trying to make payment for the material, and the site was telling me not available. I don't know the link that. Thank you.
Okay, that will be network issue. Yeah, that will be network issue, but the form is still open. So maybe later you try again tonight after this session.
Yes, I also have another question. The carboxylic acid. How do we add it? Then I saw the benzene C66H5, then C2H5. Okay. Okay, we can add 66H5, C2H5. How do we add that one?
Okay. I'm going to start afresh. Yeah, so I'm going to start afresh so that we'll be carried along very well. But one thing I must tell you is that we are not going to, we are not learning how to use ChemSketch as a whole, because there are some questions that will come along the line which will involve explaining some of the features of ChemSketch. So we are just going to use the ones we need in this training. So meanwhile, there is a training coming up last week of this month. That is on 28th on beginners training, beginners course. That one is basically on computational chemistry. So we're using ChemDraw and ChemSketch for that training. So I would advise some of you to join that beginners course. It's just 5,000 instead of 20,000. It's just 5,000 for that beginners course. It was designed for undergraduates, but a beginner who wishes to get experience in structural softwares can also join that training. So, but I will still attend to your questions to the best I can. But just know that we are not teaching how to use ChemSketch here, but we are teaching how to just use it in designing molecules. There are many things in ChemSketch. I will try my best to attend to your questions. Before I go, we had a pending question yesterday. Somebody was asking if we have something like this. This was what we had, and the person was asking about this. So the person was that I want CH2 to show here. That was the question, that person, which I replied that you should try changing the style, the drawing style. So, but one thing you can just do, if you want that your carbons to appear, just use your edit atom. below this test, look at my cursor. Below the test, there is this alphabet A, edit atom. So once you make use of the edit atom, you click on the edit atom, then come to where you want to type. So I want to type CH2 here. This CH2 that is showing here, I want it to appear if I leave the cursor. So you click on that node where you want it to appear and type CH2. So once you type CH2, you insert. Then it will bring up, it will show the CH2. So the CH2 will appear because you are using edit atom. So this is now CH2, CH3. Now, but if you don't want it to also be like CH2, CH3, you want everything to be there like C2H5. You don't want to extend it. Then you can delete this. You can delete some of the one you have done. You can delete these parts, this CH3 part. Then you can also use edit atom as well. That's an edit atom. Click on this CH3 now and type C2H5. So once you type C2H5 and click insert, so C2H5 will also appear. Just like that, if you don't want to extend it. So you can make use of edit atom. You can use edit atom. All right. Hope we are together.
Yes, sir.
Yes, sir.
Okay. All right, thank you. So what we want to do now is we want to build our analogs. I shared with you some journals, about 2 or 3 journals in the folder for those who made that commitment field. So if you have seen those journals, you can be able to see that those journals are some anti-cancer research that we are done with derivatives. You can see how they formed their derivatives. So while we are building these molecules, we want to build up to more than 50. How do we do that? In this case, we have established just two different patterns for A and for B. Now, since I have four different positions, I have R1, R2, R3, R4. I'm giving you the basic principle now you need. Because most times you may end up building 50, and out of that 50, 10 happens to be similar, happens to be the same. 10 may happen to be the same name. Like this is what I'm trying to say. If I have this, now, let me show you. There are 2 benzene here. Okay, better I should have just used one. Okay, I have this. I want to show you something. This is here, and this is here, because I'm not after we building as much as possible, but having the foundational knowledge. There are certain principles that you need to be exposed to. I want to explain something here. Okay. Now look at these 2 molecules. I know some of us who are good at chemistry will be able to give us a good answer from this. So this is molecule A. This is compound A. and this is compound B. So I have a question to ask. Compound A and B, are they the same compound or different?
Different. I mean, same rather, same.
They are the same.
They are
the same
same, right?
Just the
They
name
are
of
so much.
the functional group that is
Good.
changing.
In fact, I will not even say they are isomers. They
They are
are
not
exactly
isomers.
the same.
They are
Yeah,
the
they're
same
not.
They are
compound.
the
It's
same
just
thing. No ISO. They are not
rotation
They
isomers.
are the
of the
same
positions.
compound.
Configuration
Yeah,
of
their position.
the functional group.
Good. Because both of them are at the para positions. Both of them are at the para positions. So they are the same. That means that one who don't have good knowledge of symmetric and asymmetric positions in organic compound may end up building something like this, thinking that it has developed different compounds, not knowing that at the end, you just achieve the same thing. So you take note of the positions that will not give you the same compound. This was, I had a training by June last year, and my students, a few of my students, they built 100 molecules. 25 happens to be repetition. It was repeated because when we generated the smile code and the name, the EUPAT name, they were the same because they didn't pay attention to the symmetric positions. So while you are giving positions like R1, R2, R3, R4, make sure that those positions you are assigning will not end up having the same compound. They will not end up having the same compound. That is very, very important. So on that note, you can figure that out by yourself. Then another key point I would like to share with you now. I've explained about the symmetric positions you know they play in repetition. Then another key point you must know while you are developing your compounds is it is very possible to build up to 500. Like in the mini project we'll do after now. The mini project, I will give you 1 week. So by next week, Saturday, we shall be defending the mini project. Next week, Saturday. So you have from now till next week. You are going to develop up to 100 or more, but at least 100. Now, with this A and B that I have here, I can build 50, or I can build accurately 48. This A and B can give me 48 analogs. Only this A can give me 24 analogs. This B also can give me 28 analogs. How will I do that? It's simply based on permutation. Based on permutation. You will just ask yourself, since I have 4 positions, in how many ways will I arrange these 4 positions without repetition? Okay? In how many ways will I arrange these 4 positions without repetition? So once you're able to calculate that permutation, of course, there are 4 items. There are 4 positions. So once you can use n factorial, you can use n factorial as the formula to explain that that equation. Sorry that I really need to explain all this because the building is not a problem, but the problem is understanding what you are doing. So you can use permutation. by asking yourself, in how many ways, in how many ways can I arrange these 4 positions such that they will not repeat? So you can use this equation of permutation, which is 4 factorial, n factorial. So n here represent the number of positions. So I have 4 positions, R1, R2, R3, and I want to alter them so that my R1 must not be OH or my R2 must not be NH2. It can alter, but such that I will not have repetition and exact repetition. So in how many ways can it be arranged? So you can use this formula by saying 4 factorial. And when we talk about factorial, when we talk about 4 factorial, it simply means you multiply 4, 3, 2, 1. So multiply that number to the end. So like what I mean by 4 factorial now, 4 factorial will be equal to 4 times 3 times 2 times 1. That will be giving me 24. So 4 times 3, 12. 12 times 2, 24. 24 times 1, 24. So there are 24 ways of arranging these 4 positions without repetition. So are we together?
Yes, sir.
All right. So now what you just need to do now is to arrange that. It is now your duty to create a table. You can create a table that will have your column. Your columns might be the R1, R2, R3. Then you alter them such a way that there will be no repetition. But and you should achieve up to 24. So if you're able to set five different scheme, 5 different pattern. So each pattern, when you have 4 position, is giving you 24. So imagine you have 5 positions. That is 5 factorial. You will know how many analogs you should have. So, but we are working with these 4 positions, and I have like 5 different stream A, B, C, D, and E. 5 different stream. So each stream 24, each stream 24, 24. So I have 24 times 5. So that you have achieved more than 100. Then if you can also develop more stream, why we are doing this is so we can alter the positions. So by the time we do docking, we can be able to see the ones that might be better. These are the process. These are what we do in lead optimization. So in some papers, you will see 200 ligands. Then you dock them the same time. Do you have a question before I proceed? Do you have a question? Okay, I think there is no question.
No question. Continue. No question, sir. Continue.
Okay, so since we have been able to understand, we have been able to understand this principle, the next thing we'll do is, how do I arrange them to avoid repetition? If you can use your AI can help you to arrange this your positions to avoid repetition. So let's just quickly, I will use AI to do this first one. So we can have 24. Then we'll see how we can build that 24. Okay? Because if you decide to do that manually by yourself, you might even end up making a mistake. So let me just let me copy them. Let me copy.
Hello, sir.
Yes, I'm with you.
Sir,
Yes,
for instance,
yeah.
if you were to use your own thing, that is, if you want to use not use AI, is this so hard or difficult to use this to apply this fermentation? Because you made mention that you may end up of getting some repetition.
To use what?
I said if
Please
you were
come
not
again.
to use AI, can you hear me? Hello?
Yes, I can hear you.
I said if you
Yeah, I
decide
can hear
not to
you.
use AI, if you can decide not to use AI, how do you
Yes.
apply this computation to get it done without repetitions?
Okay. 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 you like hardware, right?
No, sir.
Do you like? Okay. All right. Let me show you how you can achieve that. Let me show you how you can achieve that. Let me use my Excel sheet, or you can use okay. Let me create a table. So I will just show you a tip. But definitely, if you are building large data, you are going to definitely make some mistake. Except you are very, very, very good at it. So let me create my table first. This table will be my screen. So I will use this table as a guide. So I will have analogs. Can you see my screen?
Yes, sir.
Yes, sir, we can.
So I'll have my analog. I will have my arrow 1, my arrow 2, arrow 3, and the arrow 4. So what was this is analog 1, analog 2, 3, 4, 5, 6, 7. Okay, so what was my analog 1? OH, right?
Yes, OH, NH2.
Okay, I think, okay. OH, NH2, CH3, and C, the bond O. So he's asking, how can I achieve 24
We
without
cannot see
repetition
your
since I don't want to use
screen.
AI
Oh.
to arrange? That will be network from your end. Yeah, that will be network from your end. So see what you will do now. I won't do all, but I don't like stress. What we'll do is we have this first. Then I copy this to another cell. So I will just alter this. I will make this one C, the bond O. Now make here my CH3. I've achieved 2 different compounds. Hope you know that.
Yes.
Yes. So I go again. What I will now do is this thing will stress me. I don't have that time to start stress my brain. I will then change. Okay, let me just make this 4 first. So I've altered number 1 and 2. Number 3 now, I might decide to alter NH2 by making here CH3, and the NH2 here. Then my NH2 here. Then, yes, I can hear you. So here, I can take up this. Yes, I can hear you. Somebody mentioned my name. So I can now take here to be C double bond O, and here become my NH2. So you see how I'm altering it. I just achieved 4 for now. So you can, because I kept R1 constant, change others. So you can also do that, keeping R2 constant, change others, then keep R3, change others. So you can see how you be able to do so. You achieve up to 24, but it will be tasking. So I will encourage you to just, why not to just employ AI to help you arrange it for you without repetition. So is that taking Salisi?
Yes, sir. Yes, sir. Thank you.
All right, yeah.
And
Yes.
sorry, sir. So that means you have to keep just one constant, and the rest can change.
Yes. Then you can, after you are done with that set, another set, you keep the other one constant and change the rest.
Mm.
So by the time you have 4 into, by the time you have kept 4 constant, 4. So and then alter others, you achieve 24.
Okay. Okay, because I did it first and I got only 16. So I was a bit confused how the remaining 8.
Okay.
Okay.
Yes, you must have that you must have that 24. So let's quickly use AI to generate that and to save us that stress. I'm going to copy this table. Then let me see. But even if you are using AI, you can still verify what you are doing. So let me say, arrange this table in 24 possible ways. In 24 possible ways without repetition. Without repetition. So let's see what that will be for us. Okay. All right. So we are good to go, right? So I will just copy it. Are we together?
Yes, sir.
Yes, sir.
Yeah. So I will just
Yes.
I will just copy it. Thank you. I will just copy it to my documents. Then I'll paste to. So this will now guide me in building my structures. So this will guide me in
Sir, I have
building
a
my
question.
structures. Yeah, go ahead.
Like we use AI to get the different analogs. What about the
Yes.
pharmacokinetics parameters and others? It is satisfied? Like after we
Parameters,
design the
I don't
compound,
understand.
like after we design, we use AI to get different analog of the compound. So what about
Yes.
the pharmacokinetic parameters and toxicity profile of the drugs, of the
Okay.
design compound?
Yes. Our idea here, like I explained that yesterday, that pharmacophoric features does not have direct impact on pharmacokinetics
Pharmacokinetic
properties.
parameters.
Yes.
Okay.
So it is the entire structure of the compounds that has effects on those properties. So maybe what you can do now is to also ease your work after you have created your analogs. You cannot
Yes.
move from here now. You cannot move from these analogs to
Yes.
admets until you have designed the molecules.
Yes.
Because what we use
My question is that
is
after
my
we design the compound. Okay.
Yeah, so you can use their SMILE code to do
Okay.
admit studies.
To check their
Yeah,
properties.
yes. So you can
That
filter out the
means
ones.
some of the
Yeah, go ahead.
that means some of the compound may fail. May fail
Yeah,
this.
may fail. In admits, they may fail. Yeah, they may
That means
fail in
after
admits.
we design the compound need to undergo pharmacokinetics properties and
Yes.
toxicity profile check.
Yeah. So you can screen out the ones that are toxic and use the ones that are non-toxic and continue with your work. Yeah, that's
Okay,
a
thank
good.
you.
That's a good question. So that is why I will encourage you to do more than 100, because the larger the better. So this 24 was just in one scheme that we created. So you can create 5 different. You can create scheme anyhow. You can just create scheme anyhow by yourself and then develop the analogs from there. So I will take this. I will take this my.
Hello, sir.
Yeah.
I
Yes,
have
go
a
ahead.
question.
Yeah, go ahead.
When you were talking about getting different arrangements of the compound, then at least one will be constant 4 times before you get to the next one. So when you instructed AI to give you different arrangements, you did not imply, you instruct us to keep one constant. That is not too clear to me, because what I get from that is that AI will just give you, will reshuffle everything to get as many as possible. So how did you achieve that? That's the constant compound.
Yes.
The compound is supposed to be constant.
Okay. You know why I explained that while you are doing that manually, you keep some of the features constant, then alter the other one. That one that is constant will not be constant all through. Like OH in Arowa will not be OH all through. So later you come and maybe put NH2 constant 2 and alter the rest. Later you keep CH3 constant and alter the rest. Now that will guide you manually, because you are building it manually. It will guide you while building that structure manually. But AI understands that since you have 4 positions, you cannot generate more than 24 possible ways, because from the factorial, 4 positions will give you 24 possible outcomes. So AI will just generate those 24 possible outcomes without even repetition. Now, if you look at what AI did now, the R1 OH, we are constant up to 6, number 6. The OH was constant. So AI understands that some will be constant while others will be varied. If you look at from 7 to 12, NH2 was even kept constant, others were varied. Then from 13 to 17, CH3 kept constant, others from 17 to 18, CH3 was constant, others were varied. From 19 to 24, the carbonyl was constant, others varied. So that is the whole idea, that there must be constant while others will be varied.
Okay, thank you very much, sir.
All right. So it is not possible for AI to generate more than 24. Okay, so I will copy this to my claim sketch so it will be easier for me to look and build. So we are going to write down right now. I think I've explained most of the things I needed to explain for us. So any other explanation will come later, except you have a question to ask.
Sorry, I still have issue with moving a molecule to an edge.
Okay, I will attend to that. I will attend to that. I want to set mine so that it will be easier for me. All right. So we are good to go. I believe you can see my screen clearly. I can take off this now. I don't need it again. So I don't need it again for now. Okay. So if you want to move, let me address that issue now. If you want to move your compounds, just click on it. Select, go to this structure first. Then click on select. Click on select. When you
don't see
I can't see your
anything,
cursor.
sir.
Where is your cursor?
this is my cursor on select. On select.
Yes. Where is it? Okay.
On this select. Select. Can you see select?
Okay, like ball. Okay.
Yes. Like ball. At the top left. Top left. So once you click on it first, then come to that structure you want to move. That structure you want to move. Click on the structure you want to move. Hold your left mouse, then drag to anywhere you want to drag. Oh, sorry. Hold your left mouse. So once you click on the structure, see what you do to make it easier for you. You move your cursor towards the center. Once you move the cursor towards the center of that molecule, it will show this something like plus. The cursor will be something like plus. Look at my cursor. Please, if your mic is on, mute your mic, please. So what I say you should do is click on select, then click on the structure. Once you click on the structure, look at select, that thing like ball with arrow pointing on it. See my cursor. See where my cursor is at the top left. Top left.
Okay.
Yes. So once you click on select, then click on the structure you want to move. Once you click on the structure, you will see that the structure will be selected. Then move your cursor a bit towards the center. Once you move it towards the center, the cursor will change with something like four-headed arrows. So once the cursor now bears four-headed arrows, hold your left mouse, then start dragging. You see how I'm dragging it now? So, but your left mouse must be held while you are dragging. So is that okay?
Yes.
All right. So let's start. Let's build. Let's build. Hello?
Yes, sir. Sorry, I didn't attend yet. Just trying to install. I just installed my own Kendrill now, and I'm trying to. It's showing as a compressed zip file. I don't know how to.
That would have been my. I can't. Sorry, I can't. Okay. See, just click on that zip file. Just not what I'm saying now. Let me be fast with it because I'm supposed not to attend to that now. That would have been nonsense. Click on the zip file, double click. Once you double click, it will open. Once it opens, you will see a file named info. You see a file named info. double click
Yes,
on
sir.
that info. The info will open. Then you will see setup.
Yes, sir.
You will see setup. Then double click on setup. Then follow the process to install.
All right.
I repeat,
Thank you.
that downloaded file, that zip file, double click on it, it will open. Then you will see info. Once you see info, double click on that info folder. The info will open. Then you will see setup. You see the setup file, bearing application. Double click on that
Okay.
setup file. Then they will ask you, do you want to install this or make it whatever? Say yes. Then continue clicking next. You know how to install from there.
All right. Thank you very much, sir. Sorry for the truth.
You're welcome. No problem. All right, thank you. Please, so sorry for that interruption. Just how to do that. So what do we do now? We copy this. We copy and paste. So I copy and paste. I already have my table is there already. So I don't have business to start cracking my brain. I will start doing what I have in my table. For my number one, our one is OH. So I'll pick,
It's like the network is. I'm not seeing your screen again.
that is network from your end. Is anybody see my screen?
Yes,
Yes.
Yes,
I can see.
All right, thank you. So what we just do now is pick. You want to put OH in number one. R1 is OH, so you go to O, type, paste it in your R1 to be OH. N2, your R2 is NH2. Go to R, then pick N to R2. It will show NH2. R3 is CH3. So pick carbon. Go to R3. It becomes CH3. Then R4 is C double bond O. This C double bond O, I'm going to use C double bond O. That thing will be an issue, but let me see. That C double bond O will be from a ketone. I will be from a ketone. That will be from a ketone.
If it's not an issue, just go to your right-hand corner. You will see the bond O there.
But that one will be from carboxylic. Okay, let's use from carboxylic acid.
Okay.
Let's use from carboxylic acid. So we'll just pick this COOH and paste it there. Let me use that one. So from here,
Sorry, please help me to try the edit atom.
see the bond O. Okay, this is better. This is better.
Network.
I'm coming. Okay, COO. No.
Sorry, hello, please help me to try the edit atom.
You can type it out.
Yeah, you can use edit atom, but I don't want to use edit atom here. Okay, let's work with this one. But this is not giving me exactly what I want. For see the please, if your mic is on, you can mute it. See what I want to do. I will attach it here. All right. So this is what I wanted. So are we clear now? Now we have built R1, R2, R3, and all that. So this is number one. For you to do number two, you can just copy this number one I have built, copy it, and paste. below. Then the only difference is I'm only changing my R3 and R4. I'm only changing R3 and R4. So on that note, this the R4 here will now be my CH3. So this is CH3. Why this place will be my ketone. So are we clear?
Yes.
Good. Then I want to build the third one. My O remains as R1, but the R2, the N2 will now change. So I can decide to also pick this. So you just have to be careful while doing that. Why doing that? To avoid mistake. So you copy and paste. When you copy and paste, you check. R1 remains OH. R2 now becomes CH3. So I will pick my carbon and replace my nitrogen to give me CH3. The R3 becomes nitrogen. So I will remove what is here so I can have nitrogen. So I'll pick my nitrogen and replace here so I can have NH2 as the R3. While the C bond O remains at the end. So I can remove this CH3 here and pick my carbonyl, then attach it here. So I have built the third one. So you see, it is not difficult. You can keep altering it this way. Then to build the fourth one, our OH remains OH number 1, CH3 number 2. So I'm going to pick this fourth one. I will copy the fourth one and paste. So please, I will not be able to do all because I'm just showing you. I'm just showing you. So I'll not be able to do all the 24. Please, if I do up to 5, then we proceed to other business. Hope it's okay.
Yes, sir.
Hello, sir.
Uh-huh.
Hello, sir.
So I'm at the fourth one. My OH remains number 1. My CH3 remains number 2. But my number 3 now is my ketone, my carbonyl.
Hello, can you hear me?
I can hear you.
Go
ahead. I can hear you.
Look at
the network is bridge. I can't hear you clear.
Hello, sir.
Yes.
And the second structure, the night group is attached.
Please,
can
you go again? Can you explain again? Can you repeat your question?
Yeah, on this structures.
Which are the structure?
Let's take, for example, the structure number 1. That's structure number 1.
All right.
Where we have the carbon. You have the group.
Oh, I'm not getting you clear.
Hello, sir.
Is there anyone that understands this question that can help me so I can hear clear? I'm not having it. The thing is breaking.
Hello, sir.
Yeah, I can hear you.
Sir, actually, I lost since from the beginning. That is for analogs number 1. in the
Okay.
RQ. In the RQ under carboxylic group. I mean under carbonyl carbon. Because I understand that under RQ you should have CO double bond. But here apart from CO double bond in the structure, I can still see CH3. Why do we have CH3 again?
Okay.
Exactly. Exactly. That was my question.
Okay. Now, we cannot just have C double bond O like that, because whenever you see C double bond O, that means that group must be a ketone group. When you see just C double bond O, it is a ketone group. So, but most persons, they decide to attach COCH3. But anytime you see C double bond O, then it is a ketone group, because it has no substituent. Like unlike C double bond O. Okay, let me do this and explain something to you. Let me use.
Hello, sir.
Yeah, I'm coming. Yes. Now, don't let me finish up. Look at these three things. Can you see these three structures here?
Yes, sir.
Good. They are all different. They are all different. The first one is a carboxylic acid. It has C double bond O, single bond OH. That is a carboxylic acid. Here is a ketone, because it has double bond O, single bond benzene. Then this place cannot be any other substituents can attach here. So I can make it simple for you by adding these stuffs here, so it will be easier for you to understand. All right. So at this point, this first one is C double bond O. This first one now is C double bond O. I'm coming. This is C double bond O, single bond OH. This is a carboxylic acid group. But this is a ketone. So number 1 and 2 are ketone. So whenever you see just C double bond O without having any functional group attached to it, just know that it is from a ketone. A ketone group have 2 alkyl substituents. So the C double bond O comes at the center, in between, while the alkyl comes at the terminals. So since our R4 is saying C double bond O, I cannot just put only C double bond O. The tetravalent nature of the carbon connected to the oxygen will not be complete. So if I decide to just write only C double bond O, only C double bond O is not complete, because you will now notice that this carbon here is carrying a hydrogen. And once this carbon is carrying a hydrogen, that becomes an aldehyde. And I don't want an aldehyde, because C double bond O single bond H is aldehyde. So I just want it to remain as a ketone. That's the reason why you are seeing CH3. So that is why you are seeing CH3, to balance it up. Okay. So if I needed a ketone, it would have been COH. Instead of writing CO, I would have said COH.
Say what I want to say now, sir.
Yes. So I would have said COH. That shows is a ketone. That shows is an aldehyde. If I want aldehyde, I would have said COH. So COH is for aldehyde. But since I just said CO, your mind will come to ketone. But if I want it to be easier for you to understand, I would say RCOR. Or I would say COCH3. So once I say COCH3, then I've made it easier for you that it is a ketone that is ending with a terminal alkyl. So why we are putting CH3 is to make it a ketone, because if we leave it as H, that becomes aldehyde. Thank you. Yeah, somebody wanted to say something again.
Exactly, sir. It's where you handed it that I want to direct our attention is to make it simpler. I want to suggest that in that our structure where we write CO, I want to suggest that we should join the CA3 to it right from the onset. Because you know, when we write the functional group of ketones, we used to write RCO, just like you said.
RCOR.
And that R can stand for any alkyl group.
Any alkyl, yeah.
I hope you get that now, sir. In order to avoid confusion, let's just include that CA3 there in that CO we are using, because the handler can be any other alkyl group apart from CA3.
Okay. Yeah.
And so far we are using CA3 here now. I want to suggest that we include this in that our C. So that we show that the alkyl group we are using is CA3 for that keto group CO.
Yes. So COCH3. So let me just do that right away. So I'm going to do that right away now. To avoid further confusion. Thank you for that, because I mentioned it at the end. Yeah. So, okay. So I'm going to copy it back. I'm going to copy it back to my work to avoid that issue. Okay. So we are good to go. All right. Any other question? Yeah. Do we have questions? Can you hear me?
Yes, I can hear you.
All right. So I've made it clear now. Yeah. I've made it clear now. So it can be easy now to assimilate. So we are at number what? We have done number 1, 2, 3, 4. So number 5 analog. We are the 5th analog. Yeah. So the 5th analog, R1 remains your. So let me copy this. So once I do this 5th one, I will now show you the next step after you must have done your analog, the next step to follow. So here, my R1 remains OH, my R2 is COCH3. So I'm going to erase this one here. I'm going to erase this and pick up my COCH3 in my R2. Then my R3 is NH2. So I'm going to erase what is here and maintain my NH2 in R3. Then the R4 is CH3. So I'll pick my carbon and make here CH3. All right. So I'll be able to design 5 analogs, 5 derivatives from benzene midazole. So one can publish this. It's publishable. I shared with you some journals that have done that. So what's the next step? Let's say we have built our models. So this first set was just for the first scheme I created. So in your project, you build 5 stream, at least 5 stream. So depending on your positions now, you can use 4 positions depending on the position you want. So you can now escalate it to to large number. Now, the next question that will come to your mind is, what is the next thing to be done after we have drawn these structures? How can we now translate this structure to docking? How do we generate the name? So there are two things we will do now. We are going to generate the name of these structures and then generate the SMILE code. The SMILE code is called chemical identity. And the SMILE code helps to identify the compound anywhere you place the SMILE code. The identity of that compound will show up. So we need two things from each of them, their names and their SMILE code. Of course, you can't draw a structure, you don't know the name. Although in most paper, they don't include their names, they just use code. Like structure 1, structure A, structure 4A, 1A, 2, 1B, like that. But we encourage you to put their name. Now, ChemSketch can only generate names for simple structure. And I believe these structures we use are simple structure. But if you have a complex structure, for those of you who like doing something big, maybe you want to start using big structure. ChemSketch may not generate name for complex structure, but ChemDraw can actually generate name for no matter how the structure is. ChemDraw can generate their name. So let's generate two things now. We generate their name and the SMILE code. Are we together?
Yes, yes,
Yes, we
yes.
are.
All right. So what do we do in generating the name and SMILE code? We click on the structure. Once you click on that structure you want, the first one, you go to Tools. Tools. When you click on Tools, then you come to Generate. Generate. You will see the first generating name for structure and then generating a SMILE notation. One other thing that ChemDraw can do is that ChemDraw can generate structure with a name. So if you have a name and you don't know the structure, you can use ChemDraw, just paste the name, it will generate the structure. But ChemSketch does not have that ability of generating a structure from name. But it can convert structure to name, but cannot convert name to structure. But it can generate structure from SMILEs. So once you have SMILE code, you can use the SMILE code to get the structure. So what we'll do now is you click on Tools and then Generate. So let's generate the name first. Click on Name. It will generate the name for you. So this first one, this is the name. This is the name for the first one. I just want to bring it down. So this is the name for this first one. 1, 6 amino, 7 hydroxy, 4 methyl, 1H, 1,3B, 1,3 benzene imidazole, 2 81 on. So you can also generate the SMILE code. Click on the structure also. Go to Tools. Still on Generate. You see SMILE notation. Click on it. It will generate the SMILE notation. You can keep it beside. So this is the SMILE notation for this compound. So if I'm doing ADMET, like what somebody asked before, conducting ADMET before going to docking, so screen out those ones that may be toxic. So you can equally take this SMILE code to your ADMET tools. It will generate their properties. Like, let me just show you. If I copy this my code, then I go to my browser, like Admet, for instance. I go to Admet. So once you paste this my code in Admet, it will pop out. Now, most times, if you take this my code to PubChem, they will not be in PubChem. Most of them may not, or few may not appear in PubChem, which means that structure has not been deposited in PubChem. But it must be found in all these kinetics tools, because those ones does not work with depository. They work by activity. So once you put the smart code, once you enter the smart code, you paste the smart code and submit, it will generate that same structure that we got. So I'm explaining this part because of the question that was asked. So can you see the screen?
Yes, I can.
So this is the structure we generated. So from the smart code, we're able to, you can still achieve that same structure we got. Then you can view the Admet properties. You can view the Admet properties for that compound. So, but this is not within our scope of study now. It's just because of someone that brought it up. So I have to show you that. All right. So the next thing we'll do again. So you repeat this for all. You come to this other one. This other one, you do the same thing for all. You go to tools, you generate the name, generate the name. So this is the name. This is the name. Then you also generate the smart code. You click on the structure and generate the smart code. Very important. So this is the first thing you will do after you have done your structure, generating your name and smart code. So you can do that for the rest. You can do that for the rest. Now, when you are done with this stage, so this is what we would like to see in your mini project. You build at least 100, generate their name, generate their smart codes. So it will not take you time. You can play around with it. Now, how can we take from here to Docker? Please, if your mic is on, kindly mute your mic so to avoid the interruption. So how do we move from what we have drawn to docking? We are going to convert these structures now from 2D, because right now they are in 2D. We are going to take them to 3D. And then we'll save them in a special file format that can be understood, that or can be readable by some of these docking tools. What we did yesterday was just to save what we have drawn as same sketch file. But we're not going to save each of them. We save each of them separately in mole file. You know that when you download a structure from PubChem, it will save as
still showing
SDF.
your screen? Or
Yes, my screen is on.
are you still showing your screen?
Yes. Can anyone see my screen?
Yes, you can see us.
Yes, sir.
All right.
We can see it now.
So you know that when you when you download a structure from PubChem, it saves as structural data file, SDF. Because people who modeled that file saved it in SDF and then uploaded. So we are going to do the same thing here. But the only difference is that CapeSketch does not save in SDF, but it saves in mol file. In mol file, MDL mol file. So we can now convert the mol file to SDF. If you have OpenBabel, you can use OpenBabel to convert the mol file to SDF. Even some database like KMBL, they have options for mol files, JSON, SDF. So you choose the file format you want. So mol file is still a structural file, but some docking softwares may not directly read mol file. So you have to convert from mol file to SDF. So what we'll do is to save each of them as mol file. So quickly, you open your 3D viewer, because we are going to keep them in 3D. They will be in 3D. So open your 3D viewer, go to this ACD Labs. Look at my cursor up. ACD Labs. Once you click on ACD Labs, yours might be in CapeSketch. Click on 3D viewer. So if you click on 3D viewer, it will open this page. It will open this 3D page. Okay, I've already opened the 3D page before. So I've closed it. So come to this ACD Labs. You will see that it's showing CapeSketch, marked good. So click on 3D viewer. Once you click on 3D viewer, it will now open the 3D platform. So it will open. Somebody yesterday was saying that when he downloaded CapeSketch, he saw 3D and Chem Basic. So the same thing to when if you download ChemDraw, if you're using ChemDraw also comes with Chem 3D. Now the difference between this 3D of ChemDraw and ChemSketch is that the 3D of ChemSketch cannot minimize energy. It can only optimize. It can optimize the geometry. But the 3D in ChemDraw can minimize energy and also optimize the geometry. So we don't have business with minimization. We just want to get the 3D and optimize the 3D, then save it in mol file. So what we do now we have opened this 3D viewer. You come back to your CapeSketch. Come to your CapeSketch. You CapeSketch down. So once you come back to CapeSketch, you are going to please copy this name first. Control C. The first one you want to work with, copy the name by clicking on the name, Control C. So that while we are saving, we'll save with the name we copied. Then click on the structure. Click on the structure. The first structure we want to take this structure from 2D to 3D, because what we just did here is 2D. So once you have clicked on the structure, come down. You will see copy to 3D. At the bottom, you will see copy to 3D. Are we together?
Where is it?
Down, down, down. See my cursor? Down. the task bar down, just down. You see, copy to 3D.
Okay. Yes,
Have you seen it?
Yes, we are seeing.
So once you click copy to 3D, it will send that structure you clicked to 3D. So that structure will now appear in 3D. Can you see my screen now?
We are not speaking. Yes, we can see.
So once you say copy to 3D, it has sent that's what you click to 3D. Then you see 3D optimization. 3D optimization. So if you click on 3D optimization, it will optimize it. You see, something have changed. So once you click on 3D optimization, it will optimize the spatial arrangement, the geometry of those your atoms you arranged. So now that it's in 3D, let us save this structure. So you save them one by one. So imagine that you had
We can't see your screen.
my screen is still on.
We can see the screen.
The screen is on. You can see.
We can
All
see
right.
the screen. We can see
It's
the
network. The screen is still on.
So imagine that imagine that you had 200 compounds. It means you are going to save them one by one. You save them structurally one after the other. All right. So the next thing you will do now is go to file. Go to file. Click on save as. Go to file and click on save as. Click on save as. So choose where you want to save the file.
Network on your end.
So you can equally create a folder for yourself. You can create a folder so that everything you are building will be inside the folder. So you can create a folder. Let me call it benzene imidazole analogs. So I've created a folder. So I want everything to be inside that folder. What just happened now? I'm coming. Documents. Benzimidazole. Okay, this is my benzimidazole analogs. So this is save as type. Save as type. Change it from normal came sketch document. Choose the second one, MDL files. Can you see it? Yes, the second one, MDL files.
Okay, we are seeing.
Good. So once you have kept it, once you have choose that MDMO file, you have changed, you just converted what you have drawn to a structure, to a readable structure. Then change the name. That name you copied. Paste the name. That name you copied before, which I asked you to copy. Then click on save. Once you click on save, you have saved that structure as a structural file. As a structural file. So let's go to my let's go to my documents. So you see how the file now looks like. So you see how it looks like. Benzimidazole analogs. So can you see it now?
Yes, sir.
Can you see it? Now, for those of you who have a Discovery Studio, it might show like this. But if you don't have Discovery Studio, it will not show this blue icon. So don't panic. Even if your own is not showing this blue icon, don't panic. But if you have CameDraw, if you have a Discovery Studio, or if you have any visualization tools like Pymo, then it will bear the Pymo icon if you're using Pymo. If you're using Chimeria, it will also bear the Chimeria icon. But by default, I have Pymo, I have Chimeria, but I use the Discovery Studio by default, so it's bearing my icon in Discovery Studio. Are we together? Do you have any question at this point? Don't worry, I will take the questions toward the end.
I think we are lost.
But
that network messed up at the point.
We miss you.
Okay, you miss me or we or you? Let's know.
Okay, I think I'm lost.
Same here, please. I'm also lost.
But I couldn't save it in the PDF file.
Hello, not only them, which
You are not the only.
Yes.
Okay.
Okay. Let's do it again.
Please, sir, kindly go over it again for us to see better.
Yes, let me go again because it's very important.
Okay.
Yeah. You see, we are not able to move. We are not able to even look at structural based design, but there's no problem. I think I will encourage us to be part of the March training, so we can have 1 month for ourselves. There are a lot of things I ought to explain, which we may not achieve. Well, of course, we can't achieve everything in 2 days. So, but we just want to touch the most important aspects. So let me close back my 3D view. So I'm coming from fresh now. Okay. All right. So what I say we'll do is go to ACD Labs and open up 3D viewer by clicking 3D viewer. So once we click 3D viewer, the 3D viewer will open. Now, if the 3D views opens, come back to Time Sketch. There is Time Sketch below. Come click on it. So come back to your Time Sketch. Now, at this point, you'll be saving each of the structure you have drawn in 3D. First, I want to work on this first structure, so I'm going to change the name. I'll copy the name first. I'll copy the name. So click on the name and Ctrl+C, copy it. I will save it with the name. So since I've copied it, the next thing you do is click on the structure. That structure you want to send to 3D. So once you click on the structure, then you see down, copy to 3D. That same place where you click on Time Sketch, you will see copy to 3D. So once you click copy to 3D, it will only send that structure you clicked. It will only take that structure to 3D. It won't take all this structure, just that one you clicked. It will take it to 3D. So you click on copy to 3D. It will open it in 3D. So right now, the structures will open in 3D, but we need to optimize the geometry. So come down. You can do that here, or you go to Tools. In Tools, you will find 3D optimization. Under Tools, there is 3D optimization. So it's either you do that here, or very quickly, just click on this one below, 3D optimization. So once you click on 3D optimization, the structure will be optimized. The geometry will be well arranged. So we have optimized the 3D. but we cannot minimize energy because we're using chemstretch. The next thing you do is to save this 3D file. This 3D now, this structure, save it. You go to file, click on Save As. Now, so when you click on Save As, I have already generated a folder. I already created a folder for where all my structures will be. So this is the folder, benzimidazole analogs. So I will open the folder where I want all my analogs to be. Then what you will do is this save as type. If you leave it as SCD3D, it will be like a normal chemstretch file, chemstretch document. It will not be a structural file. So click on it to change it. Click this second one, MDL mole. So mole file is a structural format, mole or SDF. But chemsketch does not have SDF, whereas ChemDraw has SDF. So if I'm done with chemsketch and I want to do my docking, if my tool cannot interpret mole file, then I will use OpenBabel to convert the mole file to SDF. I think by March, all this will be detailed in that 1 month training. So choose mole file, MDL mole file. Then change the name. Paste the name you copied. So are we together at this point now? Good. Then,
Yes, sir.
Then click
We are
save.
together.
Yes, sir. Then click save. So once I click save, it has saved. So you can see what you saved by coming to that folder. If you go to the folder, you will see what you have done. So this is the structure we just saved. This is the structure we just saved. And it's a mode file. So you do this for all your structure. So let's go again. Let me just do another one for you. So we'll come back to chemsketch. It has been an interesting session. Thank you for being around. So the second one, click on the name. Copy the name first. Then click on the structure. Then click on copy to 3D. Click copy to 3D. That one that was there will go out. The new one will appear. So this is the new one. Then optimize it. Click 3D optimization. It will be optimized. You go to file. Click on save as. It's a very easy process. Then change the file format, change your name, and save. So you now have 2 files. 2 files has been saved. This is what they did. Those structures you always download from PubChem. This is how they modeled them and deposited in this database we admire. So this is how they do it. So the difference is that this is 2 meti, while there is now 4 meti. So that is how they built those structures. So you can do that over and over again. But I have a problem. Okay, any question from now? I will show you something, and I'll ask the question to know what we can do to rectify it. Any question?
Hello, sir.
Any question?
Yes. Sir, I got to know that whenever you design a chemical structures or drugs, you need to perform synthetic accessibility scope. That is to find out whether the compounds you have generated can be synthesized easily in the lab. So in this case, do we perform synthetic accessibility scope before performing dosing?
Thank you very much for that question. That is out of a reasoning mind. Thank you very much for that question. I wanted to bring this up, but I looked at it that we may not have the time to dive into that area. But since it has come on board, I think I have foundational knowledge in synthesis because I've done some organic synthesis. So I have some foundational knowledge. See, let me tell you, let's be honest. Yesterday, I told you that I built a compound 2 years ago, and we have been on the synthesis. Because even if we are working with natural products, we don't encourage isolation. I don't encourage isolation. Then we encourage synthesis. Even though some persons have debated that a compound you synthesized will not be the same compound with the one you isolated from the source. I don't know where they got that ideology, but that is by the way. So our work will end up in synthesis. Drugs are synthesized. They are not isolated. I don't think if there is a drug in the market that was produced by, how will you do mass production by isolation? Yes, how will you do mass production by isolation?
That would be very tough.
Very tough. Very tough.
That will be herbal medicine.
That will be herbal medicine. This one is very bad though. But that is the ugly truth. That is the bitter truth. But if you must go with conventional drugs, then it must be synthesized. As one who have as one that has the knowledge in synthesis, I don't just design anyhow compound. I design compounds that I'm giving you my tweet now. You pay for this. You take the synthetic accessibility. Can it easily be synthesized? You look at the mechanism that will be involved in that synthesis, the reagent that will be used, are they available within our reach? Is it the one that I will import and it will be expensive? So I consider these factors. I look at the availability of the raw materials for the synthesis. I look at the pathways. My dear, I don't go for compounds that has more than 5 synthetic pathways. Once I develop the mechanism, because I can develop mechanism, once I develop the mechanism and I see that it's, of course, I don't develop one mechanism. In synthesis, we don't develop one mechanism. I developed the last work I did, I developed 5 mechanisms. And we attempted these 5. The final product was sent for characterization. I will not tell you the end results. Let me leave that one.
Tell us now.
You know, when you ordered versatile, the
And then
problem,
they tell us so.
what we got was what we ordered versus what we got.
Wahala.
It
Tell us what you
just
got.
like what I shared before, that somebody did a work and the person said, I want to isolate
Looks like.
Tumoron from turmeric. So the person did the isolation and characterized. And then what the person got now was curcumin. So the person had to change the topic to isolation of curcumin. My God, it's not easy, my dear.
That one is funny.
We must be sincere to ourselves. So, because in synthesis, what we do is that we wait to the final product to characterize. No, you are supposed to be characterizing intermediately. At the end of each pathway, each step, you take the product, do NMR, do all the characterization. Then, if your synthesis has 5 pathways, it means that at the end of each of the synthesis, you must confirm your intermediate products, your intermediate to know that you are in line, to avoid wasting chemicals to the end. So we cannot do synthesis in our local Nigerian lab. You need a place where you'll be there with the instrument, not the one you do and send. Because at each point you are taking your intermediate, you are characterizing, get a result, then come back. Oh, okay, we are on track. You proceed to the next part. That is the whole work in synthesis. I have been privileged to partake in that business. So I make sure I look at for reagents that are accessible. You must be able to study organic reactions. You must know all those your named reactions and unnamed reactions. When I started studying synthesis, we had more than 1,000 named reactions. I started studying each of them. Reaction A's, all the one that had A, I picked it this week. I will study you. You must be familiar with them. Although we have some softwares now that can help you develop mechanism. Yes, I have a training for that this year. I have a training for that. We expose you to those software. So what you ask is a very important question. Before you build compounds that can be easily synthesized. Now you can know, maybe since you are not good at chemistry, you can know if your compound can be synthesized easily. ADMET, we saw that in ADMET. If you come back, this ADMET can tell you like here, we are seeing that this one is easy, right? Can you see my screen?
Yes, sir.
So ADMET is saying it is easy,
Yes, sir.
but this is easy by prediction. ADMET just predicted the synthetic accessibility, that it is easy, but it's by prediction. In reality, how easy it is, you must develop mechanism. Then change the raw material you want to use, the starting raw material. As a big boy, I love starting with benzene. But if I want to do this work now, I will start with the benzimidazole as my raw material. It means you must ask yourself, do I have pure benzimidazole? How much will it cost me? Then I have amino group, OH group, acrylic group, and a ketone group. What pathway can bring in these functional groups to my benzimidazole? These are things you need to ask yourself and develop the pathway. But that should not hinder you. That one is a business for other people. I believe that every compound can be synthesized, no matter how complex it is. There are people who can still do it. So if you have discovered the novel compound, you know that after you have done all this in silico process, in silico only stops at discovering the compound. Then before you go to wet lab, you must synthesize that compound now to validate it in wet lab. There will be an issue. So maybe we should pray for a better Nigeria or your country that we can have a synthetic lab where we can go and do synthesis. Thank you very much for that wonderful question. I hope I gave you what you deserved.
Thank you, sir.
Hello.
Yes.
Hello.
Yes,
After
sir.
saving the structure of the compound using 3D optimization, please, how will it be on the save file? I want to see and compare with my own that's stored here.
Okay, look at it. Can you see my screen?
Yes.
Yeah. Now, I was explaining that you don't expect your own to have this logo. My own is having a blue logo because that blue logo is for Discovery Studio. I use it for structural visualization. So that's why it's having it. But if you don't have Discovery Studio, then that logo will be like blank, white, blank. If you don't have any software that can visualize structure. But if you use Pymo, then it will carry Pymo logo. If you use Chimera, it will carry the Chimera logo. So I use Discovery Studio. I also have Pymo and others, but by default, I use Discovery Studio. So that's why it's bearing this blue icon.
My own is just giving a structure as if I'm using this sketch and drawing.
Did you save a mode file?
Yes.
You don't have problem. Even if you save, once it is in mode file, you don't have problem.
Okay.
Yeah, you don't have problem.
Mine as well, but I had to change the opening file to the Discovery Studio. So it's now looking like Discovery Studio.
All right. Yeah. You have to open with Discovery Studio, so it will open by default.
Okay. Let me try that then.
Oh, okay.
So,
do you have
so
Discovery Studio?
if I have a Discovery Studio, can I open it with Discovery Studio?
Yes, say open with. Or you go to property, and change it. You go to properties, then change the format to Discovery Studio. Or you right click and you say open with. Then you select Discovery Studio. Select Discovery Studio and it will open. Okay. We almost we have less than we have 20
Yes, I have
minutes.
a question.
Yeah, go ahead.
Okay, sir. So in a case whereby we have up to like 1,000 or 500 analogs that we want to design, is there like a shorter way to do it than manually drawing for each one in a case of large analogs?
Yeah, since you want to do the design, since you said you want to do design, there's no way out. Now, but I will give you what you want. What you want is a shorter way. Now, the shorter way I will give you will not be if you want to design. Do you know I can get analogs online? In PubChem, you can get analogs, but those analogs are not the ones designed by you. They are the ones already designed and deposited. But if you want this one that I want to design it myself, there's no shortcut.
Okay, sir.
Okay. So, boy, if you want just to get analogs, anyhow analogs, those analogs you get in PubChem, they may not have these features, these pharmacophoric features we are talking about. But I will explain that more in the class we have next 2 weeks, where we can retrieve up to 1,000 analogs online. then screen them to select just the ones that have the pharmacophoric features we want and leave others. But it means that those structures are not novel. You are not the one that built them. But here, we are creating them by ourselves. Fortunately, most of the ones we've been created by ourselves must have been found online. But most times too, from experience, some of the structures we build, when we go to PubChem to search for them, they will say no record found. Means it has not been deposited online. So if you are designing by yourself, you must follow this.
Sir, even if the structures are not found in PubChem, some are used to be found in Science Finder.
Yes, good. KBL and others. So you search in other. I use about 5 database. I use about 5 chemical database. My personal self.
Science Finder, PubChem,
Yes.
Chembol, and
in fact, I have a record
So,
for myself. I have a record here. I have up to 50 database for chemical structures for myself.
So can I use a zinc farmer as well?
Sure, you can use. There are many chemical database. There are many. You can use zinc farmer. You can use zinc dust.
Yeah. Hello, sir.
Yes.
So with regards to the question that previous participant asked about if we can generate these structures automatically. It's like last week I saw one research for using AI for de novo design of a particular inhibitors, where they use the non-inhibitors from Campbell, and then they now design some Python codes to train the machine learning with that non-inhibitors, and then they now design new compounds out of those inhibitors that were run with.
Yes, it is possible because those things are generated automatically. But the idea here is that if you really want I want myself, I want this design to come from my brain, then there is no way out than this.
So they use permutation. So they also use permutation. That is, it's like they give instructions to how they want the compound to be. Just like what you did with
yes,
AI
you can
now.
instruct AI. You can instruct AI. There are AI tools where you can instruct AI. These are my Pharmacophore. Then give him the permutation you want. It will now generate those structures based on the positions you have supplied. It is possible.
And we can still call it de novo design. We can still call it as a novel, something that you are going that.
Yes. It's still novel. It is a novel because you supplied the Pharmacophore you want. What AI did is just to generate their structures. So it is possible. Yes. Thank you. So I think I'm going to introduce that. I will introduce that in the March training. I will bring this up in the March training, in the March training, so that it can be easier for us. All right.
Thank you, sir. Sir, I still have issues with my jump sketch.
All right. Yeah, what's the issue?
So actually, when I am trying to put something like OH in the benzene ring, it's not cooperating actually, sir. So I don't know if I'm the one doing it wrong.
Oh. Can I?
Yes, I can share my screen.
Okay, let me allow you to share your screen. So we'll end from there. We'll summarize from there. So let me stop sharing so you can share your screen. We have 4 minutes to do. I really want to appreciate us for being around. It is not easy. Some of us goes to work and we come back. We still have to find a way to still learn.
Sorry.
You're learning in Nigeria.
Sorry, since we are unable
Somebody will tell you.
to reach structural based design, are you also attaching the video?
No. I'm only sending video of what we did. We are unable to look at it, so that will be adjusted to match, please. I have classes every day, so I may not have that time to do a video on structural based and send. So you just have this one we did. It's okay. You can start doing something with this one. Now, but the structural base is not difficult. Maybe I'll just use 10 minutes and show you something. Then you can build on it.
Okay.
All right. So if you have not made that commitment fee, I would advise you to do that so you can get access to what we are doing now. Is we are not just giving you video, we are providing summary notes of the class so you can easily read and get the summary of what we did. We are providing supplementary materials, some journals that will guide you to see what people have done. Then we are preparing some tests, some short tests, some test books, some test materials that talks about what we are doing, so that it will really help you for those who have time to read. Yeah, Salusi, I'm waiting for you to share. I saw your screen before and it went off.
Okay, actually, I'm trying to share it, but
I saw the screen and then it went off. So we are trying to improve day by day to see that we have a quality delivery, and it's not about the money, but it's about what we are, the impact we are trying to create. Yes. By next week, we have webinar next week. Who will discuss? That one is discussion. Then by the upper week, we have another free workshop, which is molecular modeling. Then by the 4th week, we have a beginner course on computational chemistry. So look for this trainings and register. Then our monthly training for January starting next week on pharmacognosy. That one, like somebody said about herbal drug, we want to see how we can turn our medicinal plants into medicinal products. That is pharmacognosy. Nigeria, we are blessed. I traveled yesterday. On the way, I was just looking at our forestry, our vegetation. I saw that we are blessed in Nigeria. But then, how many herbal products do we have here that has been commercialized and exported? How many of our pharmaceutical shops, our pharmacies, how many of them sell a herbal products? That ideology is still hidden. Even some of you, if you take herbal products, you won't like to take them. You love taking the conventional drugs. So we want to do that training on pharmacognosy to see what we can do, how we can turn our medicinal plants from plant to medicine. It's just 20,000. All our monthly trainings are 20,000 instead of 50,000. So you can join us. By February, I will appreciate you also enroll in that February training on mastering green chemistry. Mastering green chemistry is coming up from the 10th of February. Immediately we end pharmacognosy, the 1 month, then we enter 1 month for green chemistry. Then once we end the 1 month on green chemistry, we are entering 1 month on this Pharmacophore. So every month, have every week, every month, every day is occupied. Trainings, free webinar, beginner course, paid training every month. Enroll. I have someone here. I was even asking myself, it's not that the person has money, but he's just applying all the training. And what we are trying to do is that we are trying to now bring in a referral bonus. So we shall be giving you 5% referral bonus. So once you refer someone that registered, you are earning 5% off your money that you registered. So we will fund you 5%. So by the time you have referred as much as possible, to each person you refer, 5%. 5% goes to you, 5% goes to you. So that is to encourage us. And we really appreciate some of us who shared our adverts. We really appreciate you. Thank you so much. Thank you so much.
Can you now see the screen?
Yes, I'm seeing your screen. So what is your issue now? Yeah, what is the
now
issue?
You can see the benzene here, huh?
Yes. So what do you want to do now?
Let's assume I want to have a phenol. That is benzene ring with OH. Now, if I click on O, I hope you can see my keyboard. Yeah.
Okay.
So you see, sir, what is here?
Okay.
You're wrong, bro. He's
No,
wrong, bro.
you're wrong. First of all, bring
That
out the bond, because the OH you want to attach will not be among the chain, among the ring. Is a outside. So take your draw number and click on that place. First pick draw number. Pick your draw number. Good, you're on it. Click on the carbon where you want to extend that OH.
Okay, you see?
Just click anywhere you want.
Yeah.
Okay, no. Okay, change. Okay, no. Redo, please. Undo. Undo. Your atom is on oxygen. Let it be on carbon.
Uh-huh.
And let it be on carbon. Now I see. Your atom is on oxygen. Let it be on carbon.
Now I should click
redo this thing, undo it. Control Z. Just do Control Z now. Control Z. Good. So go to carbon. Pick your carbon. Pick carbon. Pick carbon now. Place the benzene now. Place the benzene. Place your benzene first. Pick your carbon. Pick the carbon.
This one?
Carbon. See, go to carbon.
To remove the benzene now.
Then click anywhere now. Click on any of the terminal carbons. Good. Click. Fine. So now you want to put OH. Your OH now will now replace that CH3. So pick oxygen now and click on that CH3 to now turn to OH. And so click on that CH3 now. So it turn to OH. Is that the issue?
Yes, sir.
All right, you're welcome.
Sorry, what of carboxylic acid?
The same way too, you must extend an alkyl. You extend an alkyl first, you extend the carbon first. Then there is carboxylic acid at those panel, the right panel, that is COOH. Okay, Salusi, somebody is asking for carboxylic acid. So let me do it together with you. No, first extend the carbon. Okay, well, there'll be no need. Pick your carboxylic acid. Let me see. There's COOH.
Yeah, here.
There's COOH. COOH. Click on it. Then come to one end. One of those your benzene. Yeah. So this is COOH. This is your carboxylic acid.
Yeah.
All right. So I believe the person that asked that question.
Please, I want to ask a question. For the mini program,
Yes,
Must it be on best bidders, or can we try on
No, 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 no. No, choose any one of your choice. Probably you have done, if you have done docking before, then pick a heat. Pick one of your heat in your docking results. I will appreciate for those who have docking work before, who have done docking work. I appreciate you step up from there by picking one of the heat. But if you don't have, if you have not done docking before, then you can use any scaffold, any drug. You can pick a drug, any drug of your choice, and create analogs of that drug. So you are doing at least 100, at least 100.
Please, good evening.
Sorry, can we pick from
Yeah,
the
yeah,
from
good evening.
Yeah, please, can you show me again where the draw number is, please?
Okay. Ahead. Yeah, look at the cursor. Look at his cursor.
Okay.
Look at his cursor.
Oh.
Yeah,
Okay.
he's pointing at draw number. Yeah.
Okay.
Okay. Somebody asked, can
Sorry,
we use
sorry.
complete?
If it
Yes.
is C double bond.
Double bond.
Yes, C double bond.
Yes. Once you click
C double bond
on
0.
a single bond, it becomes double bond. So just click on that single bond. Yes, yes. So listen, click on that single bond to O. That single bond, that OH single bond. Once you click on it, it becomes a double bond.
Where, sir?
The OH single in your phenol,
Okay.
in the phenol, in the phenol, click on that single bond to OH. So once you click on that single bond, it will now become a double bond. Take your draw normal. It's not moving.
Remove the benzene ring first.
No, don't draw a new. Don't draw new. Don't draw anything new. Just let's use this first benzene ring you have. Let me just show him about the double bond. Once you take your draw number and click on a single bond, it becomes a double bond. That is it. Then if you click again, it becomes a triple bond.
But it's not doing.
All right. So I really want to once again appreciate us for. I'm not seeing what you are doing, sir. I'm not seeing what you have done.
Yes. So I'm clicking on draw normal and then I'm clicking on the single bond. But
You have not done anything. I've not seen anything you have done.
Can you see my
Once you click on the draw number, just go to the bond and click on the bond. You click the bond and you click out.
This is why I should click back.
Yes, I click on the bond, the line as it is now.
It will work. It will work. It will work.
Click.
I think the carbon is saturated already. The carbon is saturated already. The carbon is saturated already.
Don't worry. I'm seeing a question. They say, please, sir, ensure we have the video of this that you did for us in green chemistry. Yes, unless it is saturated, so it will not create. Yes, saturated.
It is saturated. We have
because you already have
4 bonds on that carbon.
You already have 2 bonds. You have 4 bonds already, so it's saturated.
Exactly.
It will work.
Exactly.
So if you want to do that now, take your cyclohexane. You can do that from cyclohexane. And you can pick cyclohexane to illustrate that for him. Yeah. Thank you. So, please, we notice that some of you have made payment but have not filled up the form. There's no way we can access your details without those forms you have filled. So after making payment, ensure you fill up the form and upload your payment proof so we can get your email and your full name So this name that was sent here, I may not use this name here. Aura, Sheshu, Ali. You ensure to wait to fill up the form. So from there we'll get your name. And somebody's asking that you supply the video as we did in green chemistry. Of course, the video will be available tomorrow. Yeah, it will be available tomorrow. Then your certificates will be available next weekend, because we are issuing 2 different kinds of certificates. We are giving out certificate of participation to those who just attended and did not do any projects, while we give certificate of completion to those who completed the project. So we are making it to be balanced. Yeah, we're making it to be balanced. Of course, you participated, you did not do any mini projects. That is certificate of participation. So we don't know if you did your work. We don't know what you did. It is when we have seen what you did that will now give you that of completion. Of course, don't think that both of them are the same. If you are presenting it somewhere, they will know that the 2 certificates are different. So we are encouraging you to do the mini project. Somebody was asking me, okay, well, we don't pay for certificate now. So that doesn't stop our mini projects. That doesn't stop our mini project. It's for your own good, though. We initiated that mini project for the good of our participants, because I've participated in some training years ago. What they after is, after they train you, pay your money, they give you a certificate. Like I've told us, in all our monthly training, the criteria to end the certificate is manuscript, not mini project again. Mini project is for our free training, but all the monthly training, you must have a paper, a manuscript, before we can issue your certificate. We want to know that you are actually applying what we are doing. We want to see what you are doing from what you are taught. That is just our aim. It's not after teaching. You want to see that you are doing something from what you are taught. And that makes you different. So we are begging you, do something. Do something. Thank you very much. Do we have any other question before we draw the curtain close?
Sure.
So if you still want to pay, you can still pay. Yeah, you can still pay. Yeah. Somebody's asking, will there be a presentation? Yes, there will be a presentation next week, start today. So no more 2 weeks break, 1 week. There will be next week, start today, there will be a presentation.
Sir, please,
Yeah.
what are we presenting on?
We build this analog, what you have done, build at least 100.
Okay,
so I will drop the guideline as usual. I will drop the guideline on what we expect to see from your work.
Okay, sir. All right, sir.
Yeah.
Hello?
So, yes, sir.
I want to use different
hello,
compound
sir.
or the compound you give on
Hello,
this
sir.
training.
No, use your
Yes, sir.
different compounds.
That
Use
next
any.
weekend is too close for some of us.
It's more than 7 days now. 7 days is not okay to build 100 compounds.
Sir, we have some other things doing also. Our place of work and so many things that we have lined up already. Please kindly extend it, please. I think 2 weeks should be okay, sir.
Please, I'm adding my voice to that because of our place of work, please. 1 week is short.
Okay.
It's not, we have other things, please.
Next
Oh,
week,
then
then why allow those that cannot make it next week, upper week.
Yeah. So, some person really need their certificate. So,
Okay, maybe
so my dear.
let some people present next week and some people present in 2 weeks' time, Abi. Please.
Or you help us with or you help us with this number of 100, maybe 50.
No. 50 is too small. 50 is too small. I cannot.
Even 57. Even 57 is much.
No, 50
that 2 weeks is better, please.
No, 50. No, 50 is too small. We cannot give it 50. Prof, will be mad at me to give it 50 compounds. We have people are designing 200 and 500. So sorry.
That's people now. We are just students. I beg. We are still on
That's
our
why
way.
that's why we are saying 100. People are doing 500, so we say 100 for students. Why 500 for people?
You are
So,
hard though.
Excuse me, sir. Good evening, sir.
Yes. Jerome.
Sir, do we have a different group? Do we have a different WhatsApp group for this class?
Sure, yes, we have now.
I don't think I'm there. Oh.
Did you register for this training?
Yeah, I registered. Of course, I registered.
If you
Yes,
registered,
definitely, sir, definitely.
the link to the WhatsApp platform was in the registration form.
Okay.
In your email, in the email.
Thank you.
Okay, what you
Thank
do?
you.
DM me. You can send me a DM. Let me add you up. Or join from the community now. Join from if you are in any of our platform, you can join from the community on the Pharmacophore. You can join. It's free.
Pharmacophore.
Yes. I noticed something. Some of you are just joining our group anyhow. Some of the groups are restricted, mostly those that have payments.
I'm guilty.
We cannot give you access unless you are registered. So sorry, because somebody have joined and I cancel. Somebody joined, I cancel. So please, I'm sorry.
I didn't know. I didn't even know.
Yeah. So thank you. Okay, do you have any other? So let me conclude. On the presentation. We are saying some who are ready next week should defend. I don't have that time for double defense. So everything 2 weeks.
God bless you.
Yeah, everything 2 weeks because
I
don't have that time for coming next week for some set of students. Then another next week again. All my days are occupied. The only day I have free time is on Sunday. So, and that is for my resting. We cannot start coming twice. So 2 weeks is okay.
Okay, sir. Please put the date on the platform. The date.
I will.
Just put the date so that we know that date is last.
Yes. Except we don't want certificate of completion. If you want certificate of participation, I will just give it to you tomorrow. You go your way.
No, 2 weeks, please. We want to complete it. I beg.
2 weeks is okay, sir.
So 2 weeks, we'll go by 2 weeks. I will drop the message on the platform.
Thank you very much.
Thank you, sir.
You're welcome. So any other question?
Pertaining the group, I can't see it on the community, and I sent a message.
The community for 2026, not for 2025.
Wow.
Get the community for 2026. Okay, if you are not there, just send me a message. But I will blame some of you who registered because the link was in that form. You skipped it.
I must have skipped it.
You skipped it. You skipped it. No problem. You can send me a DM. I will add you up to the group.
I just don't know.
No problem. I will do that later. All right. Any other question? So I'm expecting to see you next week, 17th. Save it. 17th is on Saturday. 17th by 8 p.m. for our webinar. That one is free. You're not paying. We are discussing on feature-based drug design. Feature-based drug design. Let's discuss and see a way forward.
What did you call it, sir?
Let me show.
What did you call it?
Our webinar next week. Let me share it with you. So make sure you are available. Do not move. Don't find you that day. 17th. This one is not money. You are not paying with money. You are not registering. We just register and join. This is it. So I'm sharing. I want to show you. So that you will not start complaining of I don't have money. That one, there is no certificate for that one. Everything will not be certificate. Some of you are pumping certificate everywhere. I don't know what you're doing with it. But it's good, Sha. That is what the Nigerian system has compressed us to do. So can you see my screen?
Will you post
Yes,
it on the
sir.
platform?
What is happening now? Okay, so we are privileged to have our speaker, Dr. V.O. MJ, who will be anchoring the session for us. That is our first webinar. You must have seen this in our platform because we do post it as part of our announcement. So join, register with this link. You register is on 17th by 8 p.m. Invite your friends. Let's discuss on feature-based drug design across biomedical and environmental sciences. It will be a wonderful session. Okay?
Okay.
Then, yes, while we are also preparing for that, sorry, we are concluding this session, so I just have to open up what we have in stock for you. So we can. Okay, I think that is okay for now. That's okay for now. That's okay for now. So retire back. You can retire back. Thank you very much, and God bless you. Any pending issue? I think you have treated everything.
Thank you, sir.
Yes, sir, except for the adding us to the group. Thank you, sir.
Thank you very much. God bless you.
Thank you, sir.
Add him to the group. You DM me, I will add you up.
Thank you. DM you, sir. Thank you.
Once again, I'm grateful to have you around. Thank you.
Thank you, sir. Please, which group are you adding? So I can add myself.
Thank you, sir.
Thank you, sir.